Hey, good morning and welcome back to another week. Today we are going to start off by talking about lines again. Last week we sort of examined this with slope-intercept, point slope, finding the slope of lines. Today we're going to figure out how to see if lines are parallel or perpendicular to one another. Okay, so some of you have probably already done this in Algebra 2 and Geometry, so hopefully it's a little bit of review. If not, though, just watch closely. So this first thing, parallel lines, I'm guessing most of you already know. It's when they run beside each other. They have to be on the same plane and they never meet or intersect. Okay, so lines on the same plane that never meet. All right, now when we look at this first example here, it says show that L1 and L2 are parallel. And in order to show that two lines are parallel, their slopes are going to be the same. So if we look at this first one, L1, and we see that L1 has a slope of -2/3. So now we move over to the second one. To find the slope of the second one, we first have to get it into slope-intercept form. So let's go ahead and subtract 4x from both sides. Oops. So let me rewrite that. We're going to have 6y equals -4x minus 18. Okay, divide both sides by 6. We divide both parts. Now I'm going to reduce, so 2 goes into both of those. We get -2/3 x minus 3. And our slope here is also -2/3. So since there's the same, we can verify that they are parallel. Okay, so we are done then. Now this next question, this asks us to find an equation of a line that is parallel to this line. Okay, so the first thing we want to do is find what the slope of this original line is. So we'll subtract that from both sides, and we'll get y equals -2x plus 6, which means the slope is -2. Now, since we are looking for a line that is parallel, we know it's going to have the same slope. So we can use this value right here as our slope, and this value as our point. Now, in case you forgot, jot it down here again, y minus y1 equals m times x minus x1. Some of you might need to write that down again. So that's what we talked about last week, so we'll plug this in. So y minus -3 equals -2 times x minus 2. Okay, we distribute. Also, this becomes plus 3 because it was minus a negative. And we have -2x plus 4. At this point, minus 3, y equals -2x plus 1. And that will be our answer there. Okay, so right here is our final answer. And make sure last week, some of you, when you were solving problems like this, you got it to this point and then you left it. Okay, we want to distribute, we want to solve and simplify it into slope-intercept form. Okay, so now that's parallel lines. Our next thing, perpendicular lines. Okay, and most of you probably know they cross, forming a 90-degree angle. Okay, that's the key thing. They intersect at right angles, or a 90-degree angle. And then sometimes it'll look like this, or 4 90-degree angles, or sometimes it'll look like this, the key thing, I didn't draw the straightest line there, is that it forms 90-degree angles. So it's two straight lines that cut through each other, forming four 90-degree angles here. Or sometimes it might even be a case of a line just bumps up to and only two 90-degree angles, but that would also be perpendicular. Okay, and some of you might have forgotten this, but as you can see on this picture right there, right here, anytime we are going, one line is going up and one line is going down. So there's a positive and a negative slope. Okay, so we know our slopes in this situation are going to be opposite. And our word for how the slopes compare is opposite reciprocals. All right, so now let's go ahead and find the perpendicular slope of each of these given slopes. So if we look here, 3 over 2, that's going to become the opposite. Instead of positive, it'll switch to negative. And instead of 3 over 2, reciprocal just means the top and the bottom, they switch places. Okay, so it was 3 over 2, now it's going to be 2. Whoa, that was not good. Now it's going to be 2 over 3. Not much better, but negative 2 over 3. Okay, now our next one. It was negative, so it's become positive. And it was 1 over 5, so now it's going to be 5, or if you prefer, 5 over 1. This next one, negative 8, technically is over 1. So then we can switch it. It'll become positive 1 over 8. Okay, the final one. This one is the most difficult. If we think about it, 0 could be like 0 over 1. It could be 0 over 2, 0 over 3. Either way, when you flip that, you're going to get 1 over 0, which is not possible. We can't have that. Okay, so the opposite reciprocal puts us in a spot that we don't want to have. Okay, so instead, if we have 0, remember last week we talked about that the line would go like this with its slope. So a perpendicular line to that would go straight up here if you look at the picture of me, okay, which has our slope we talked about last week, undefined. All right. So if we look here now, it says write an equation that is perpendicular to x plus 3y equals 6 and passes through the point 1, negative 2. So the first thing we want to do, once again, is find what our slope is of this initial line. So subtract x from both sides, and I get 3y equals negative x plus 6. I'll divide both sides by 3. Y equals negative 1/3 x plus 2. Okay, so this original one had a slope of negative 1/3. Now, remember, we need the opposite reciprocal. So our perpendicular slope, I'll put this little sign for perpendicular. Instead of negative is going to become positive. Instead of 1/3, switches to 3 over 1, or just 3. Now, we can go ahead and use this information and our slope right here, and we'll find our answer. So y minus negative 2 equals, now it became positive 3, then x minus 1. Okay, so we distribute that in. This becomes plus, so we get y plus 2 equals 3x minus 3. Then go ahead, subtract your 2, subtract your 2, and y equals 3x minus 5. And that is our final answer right here that I boxed in gray. Okay, so that is how we find the equations. Now, sometimes we're going to have a graph and we want to graph it. So let's take a look here, and we have this original line that we need to graph, and then we're going to label it L1, okay, line 1. So we start at negative 8, drop down 8 on the y-axis. Then it's a rise 2, run 5, or a slope of 2 over 5. So up 2 over 1, 2, 3, 4, 5. up 2 over 1, 2, 3, 4, 5. Or I can go down 2 and left 1, 2, 3, 4, 5. Okay, then we draw that line in, put arrows on both ends, and I'll label that L1. Now it says right here we need to, I'll do this one in green, graph a line that is parallel to L1, passes through this point. So we know it's going to go through over 3, up 1, 2, 3, 4. We know it's going to go through that point. It has to be parallel, which means it has to have the same slope. So right here, that's going to be our slope. So from this new point up to right 1, 2, 3, 4, 5, or down to left 1, 2, 3, 4, 5. Do that again, 1, 2, 3, 4, 5. And we can draw that line in. And yes, human error exists, but those look pretty consistent, pretty parallel. Okay. Also, let me relabel that because that was not a good label. So that one was L1, and then our new line here is L2. Okay. So now, the final thing here that we're going to graph is L3, and it says that it has to be perpendicular to L1. So L1 had a slope of 2/5, so the opposite reciprocal of that is now going to be negative 5 over 2. We know it's going to go through this point, 1, 1, so that's where we can start. And it's negative 5 over 2. So drop down 5, 1, 2, 3, 4, 5, right 2. Do that again. Or I can go up 1, 2, 3, 4, 5, and left 2. Okay, so then when I draw this line in, and hopefully you can see it forms 90-degree angles here with L1. Okay, however, if we look now up at L2, I'm hoping you see there it also formed 90-degree angles in each of those spots. So if it is perpendicular to one line, then any lines parallel with that line that it's perpendicular to will also be perpendicular. And the reason we can justify this, okay, so we need to say that they're perpendicular. And how we can justify this is their slopes are opposite reciprocals. All right, so now at the bottom here, the final thing we need to do on this notes is it says we have two tables here showing linear functions. So we know they're going to be consistent. Linear means it's a line, so the slope is consistent. It says decide if the lines are parallel, perpendicular, or neither. Justify your answer. Okay, so let's start. We need to look at the change of x, change of y for this one. You technically wouldn't have to do both because you know it's consistent, but if you want to just double check, negative 5, negative 5, yep, so that's the same. The other one, negative 4, negative 4, so those are the same. Either way, rise over run. Remember, rise over run to find slope. It's the same as our change in y's over the change in x's. Okay, and that's what m is. So we have our change of y's right here. So that goes on top. So the slope of this first one is negative 4 over negative 5, which is the change in x. Those negatives will cancel and we're left with 4 over 5. Okay, for our next one, this increases by 1, this increases by 1. Both of these increase by 3. So our slope here is 3 over 1. If we look at those, so 4/5 and 3 over 1, are they the same? No, so it can't be parallel. Are they opposite reciprocals? No way. So it can't be perpendicular. Okay, so our answer here, I'll write in blue, would be neither. And our justification, the slopes are not the same or opposite reciprocals. All right, so go ahead and practice today. We got a brief review of this lesson, just a couple questions. Please let me know if you have any questions. Remember, our test is coming up this Friday. Okay, so hope you guys have a great day. Talk to you later.